Hi guys, you're welcome back to my channel. In today's lesson, as promised earlier on my previous video, that I'll be dropping a video basically on the chemical reaction, the physical properties, and the chemical properties of alcohol. So guys, come closer. Want to take a look at the physical and the chemical properties of alcohol. Let's take a look at what we have on the board. The first one states what? They are colorless, liquid, and solid. As far as alcohol is concerned, they are always colorless, either liquid or solid. So how can we easily differentiate the solid and the liquid from the alcohol? The primary alcohol, which contain 12 carbon atoms, that is, in each every primary alcohol that are less than 12 carbon atoms, they are liquid at room temperature. Why at the other way around, if they are more than 12 carbon atoms, they are solid at room temperature. That is that for the physical state of one of the physical properties of alcohol. The second one states the boiling point increases with increase in relative molecular mass. As you can see, we have the primary alcohol, we have the secondary alcohol, and we have the tertiary alcohol. In my previous video, I explained that under the classification of alcohol. Are you with me now? So decreasing order of boiling point or increasing order of boiling order of volatility. That is, if you are given a primary alcohol, this is how you can easily show how decreasing or how increasing order they are in the volatility of the boiling point. So the third one is solubility of alcohol decreases with increase in the size of alkyl group. What does this mean? If you are given a particular thing under the solubility of alcohol, don't forget we have this. We have methanol. We have ethanol. We have propanol. The second one is other what? Butanol. That is the increasing or decreasing order of the solubility. To check if there is decrease with increase in size of the alkyl group. So these are the three main physical properties of alcohol or alkanol that you come across. There are many, but the main three types or the main physical properties of alcohol, we have the physical state, we have the boiling point, we have that of the solubility. So guys, let's quickly take a look at the chemical properties of alkanol or alcohol. The first one is acid-base properties. We have esterification, we have reaction with hydrogen halides, and for dehydration. And the last one is oxidation. So guys, when we take a look at each of these chemical properties, I will show you guys the mechanism that occur under each of the chemical properties. So guys, back to the explanation of the acid base properties under the chemical properties of alkanol or alcohol. You know, we have 5 chemical properties I want to take a look at. The first one is acid base properties. You need to know one thing, that they can be regarded as alkyl substituted water. Not one thing, the alkyl group there, they are generally known as the electron releasing. Don't forget, alkyl group are always electron releasing. With that, alkanols are less acidic than water. They are weak acid and react as acid only with a strong base. So now, how can we take a look at acid base properties and how can we differentiate it? There is one thing you need to know. When the alcohol are less acidic than water, they are weak acid. But if they react as acid using a strong base, what are we going to have? Come closer, let's take a look at that. Now, making use of ethanol, OH plus soda amide, as well as this one is A, and B, I'll be making use of ethanol plus sodium hydride. Now, let's take a look at what we are going to have to see if we are going to have a weak acid. Are you with me now? When alcohol reacting with a strong base, what are we going to have? Looking at what you have here now, this H here will attach itself to this NH2. Don't forget, I call this soda amide, and here I call this one sodium hydride. Are you with me now? So by doing that, if we are to remove this hydrogen here, the loss of hydrogen here, adding it to this NH here plus NH3, this is ammonia, and this H here would then be replaced with this sodium. So we are having C2 H5OH. This is sodium ethoxide under the alkoxy. Are you with me now? So we are not going there today. So ethanol, the same thing is applicable to. So if this particular one you have here, which is this hydrogen here, is reacting with the hydrogen under the sodium hydride, we are going to have hydrogen gas. So we have C2H5O. The sodium here will replace the hydrogen. So the sodium here will replace the hydrogen, yes, which we are having the same thing as what? Sodium hexoxide. So that is that. Now don't forget that the alkyl group are always electron releasing. And when we talk about that electron releasing, when you release electron, it means you are giving out electron, and that can easily be classified as electropositive. But if they are accepting electron, we need it to be what? The electronegative type. So guys, the second one is esterification. Esterification, alcohol reacts with alkanoic to yield alkanoates, and if the alcohol reacts with alkanoic to yield alkanoates, there is a particular catalyzed strong acid that will act. The moment you mention catalyzed strong acid, that strong acid is sulfuric acid, which we all know as hydrogen tetraoxosulfate 6, which is H2SO4, will act as what? The catalyzed. So guys, the alcohol we want to take a look at here, we are using the first one is what? Ethanol plus ethanoic. Don't forget, I said under the esterification reaction, alcohol reacts with alkanoic to yield alkanoates. Alkanoates is also known as esters. And let's see what we are going to have it. Come closer, guys. The OH here, one thing you need to know, not one thing, that under this kind of reaction, the only thing that is lost there is the hydrogen atom. It is not applicable to the what? The hydroxy. So guys, looking at what we have here now, so this is the hydrogen atom that has been lost, reacting with the OH here. What do we have here? We have C2H5. Don't forget the H2SO4, which is acting as the catalyst. And then we all know that the catalysts, they are used to speed up the rate of the chemical reaction. So guys, now that we have removed the lost hydrogen here, reacting with this OH here. I said OH plus H. What are we going to have? We have water, guys. Water. So plus water. Mind you, for the fact that you are removing your H here, and this is what? CH3COO. So guys, how can we name this kind of a compound? And not one thing, if you are to place it like this, are you with me? So you have to write by saying you have, this is a T, and initially this is ethanoic, and this is ethanol. Now, how can we name this compound? This compound is named as, see, this is our quick group, and this is an ester, so we call it eth. Now, this alkanoic here, coming to that plate at the product side, which are having the oil. The functional group of this alkanoate is COO. That is the functional group. So that will change from alkanoic oids. That will not give us ethanoids. So this is named ethanoid because of what you have here. In some cases, you can have it in this form, C2H5. So this is the best form to have ethanoid because C2H5 with this ethanoid will give us what? ethanoid. So this is the best form to write your reaction between alcohol and alkanate that will yield, or that will give us alkanate at the product site. And not only the alkanate, but the water. So guys, the forward reaction is always esterification, while the backward reaction is known to be hydrolysis. So let's take a look at the other chemical properties of alcohol. So guys, back to the third one, reaction with hydrogen halides. They react with hydrogen halide to form halogenoalkanes and water. But this reaction is carried out either by passing the dry hydrogen halide into the alcohol, or by passing a dry hydrogen halide gas into the alcohol, or by heating the alcohol, alkanol, by concentrated aqueous acid. So now, what are you trying to look at? There is that there are some inorganic halides, which are the nonmetals. So, but before we dive into the inorganic halides of the nonmetals, I have ROH. Are you with me now? Plus hydrogen halides. Then this hydrogen here will react more with this. Don't forget, we say we are going to have halogenoalkanes. So we have and water. We have water here, and we have the ROX. The X is the halogen. So now, why does those inorganic halides come in here? The inorganic halides of nonmetals act more as a catalyst. So we are going to have phosphorus trichloride, and we have phosphorus pentachloride, as well as thionyl chloride, which is this. So if you have to take a look at the third member of the alcohol, which is propanol, and pick one of these inorganic halides to act as a catalyst. So I have propanol, which is CH3, CH2, CH2, OH plus phosphorus pentachloride. So guys, what I'm going to have here, mind you, in any mechanism you are doing, or in any organic reaction you are trying to balance, always check at the examples that will show you a clear picture of what you are going to have. So guys, if we are to differentiate this and we are to split the O and H, don't forget we have OH, which is negative. Removing the oxygen from this place and this. Now we are left with what? CH3, CH2, CH2. Now this chlorine is 5. Split it. We have Cl, Cl, we have Cl, Cl, and what? Cl. So one of these is coming to this place. So we have Cl here plus. Now, don't forget that the phosphorus pentachloride has been reduced to phosphorus tetrachloride because we have removed one chlorine by adding it to this. So now, at this reactant side, we call this propanol. But moving to that place, we have removed the OH that makes it the what? The propanol. And without OH, this is what? Propane. So like I said, yeah, Cl chloropropane. Now guys, what is the next of action? So guys, this phosphorus here will attack itself, will attract the oxygen there. So now this H here, we pick one of these chlorine, so we have plus HCl. And now we are left with what? Cl3. So guys, if you are given a question under the chemical properties of alkanol, this is how we can easily deduce the answer. You can as well try with any compound. Propanol with thionyl chloride, we are going to have our answer. Propanol with phosphorus trichloride, we are going to have our answer. So now let's take the fourth one, which is the dehydration. So number 4, which is dehydration of alcohol. Alcohol are dehydrated to alkenes by excess concentrated sulfuric acid, which you all know as tetraoxosulfate 6 acid or alumina. So for that sulfuric acid, they have at 170 degrees Celsius, and or by the alumina, that one is 350 degrees Celsius by to alkene or by alkene. So guys, there's one thing you need to know is that how do we have dehydration, or how does the alcohol dehydrated to alkene? They are telling us that we have two catalysts, either the sulfuric acid at 170 degrees Celsius or the alumina, which is what? At 350 degrees Celsius. So guys, if we have this, so let's show you the mechanism. I have H here, I have OH. So this. So either I have H2SO4 or I have the alumina. So guys, for this now, it is very, very obvious that when we are talking about dehydrated, we have to have or remove water from that compound. So guys, remember looking at what you have here. When H and this react together, by say we have hydrogen plus OH, we only are going to have what? Water. So guys, for this here, for you to have removed this H here, this single bond, so we'll be having C double bond, and we also have what? The R, we also have R here, plus what? Water. So with sulfuric acid at room temperature 170, with alumina we have 350. So guys, if for example I have butan 2, which is CH3, CH, so I have C, I have H here, OH, and I have CH3. So we're having this arrow. For this, I'm going to have, so for this, I'm going to have two compounds here. So I have CH3, CH2, C double bond, I have CH2. I can as well have CH3, CH, double bond. I have CH and I have what here, guys? CH3. Are you with me now? So if this can give us both one in, we can as well have what? Both two in. That is for the dehydration. So if butane 2O is the reactant side, we can have both one in or both two in. Is that clear? So guys, that is for dehydration. So let's take a look at the land oxidation. Alkanols burn in air to form carbon dioxide and water. How do we deduce that? Alkanol, we take ethanol, which is liquid, plus air, oxygen, we have gas. So now, looking at what you have on the board now, if we are to have our answer. So guys, we're having two carbon atoms here. This CO2 plus, now we have one oxygen here plus the 6 oxygen here will give us 7. So let's say we have H2O. When alcohol is burned in air, they will form carbon dioxide, which is this, and water. So guys, let's take a look at, we have a balanced equation. 2 carbon atoms here, 2 carbon atoms, yes. 2 times 2, 4. 3 oxygen, making 7, 7 here. Hydrogen is 5 plus 1, 6. 3 times 2 is what? 6. So guys, note one thing. Note. Primary and secondary alkanol are oxidized by loss of hydrogen atom to alkana, which we all know as aldehyde, and alkanone. Alkanas and what? Alkanone. Take note. Primary and secondary alkanol are oxidized by loss of hydrogen atom to alkanas and alkanone. So guys, don't forget to subscribe to my channel.